Hello. So today I'm actually gonna do something kind of different. Hello. Uh, consider this my face reveal. For my 7 fans. Today I'm actually gonna wait. Where did I put that paper? Oh, there it is. Let me just leave this. Um, this right there. So recently in school, I've been doing performing a bit lower than usual. So what I'm doing right now is I'm gonna make a video about me reviewing the lesson on this chalkboard right here. So and when I make this then I'll just post or something. I got my practice questions right here. And anyway, what we're learning today for 6.1 is math. I'm starting off with math. We're going to start with lesson 6.1 from the unit start, even though we're in 6.2. And the reason I'm holding the mic like this is because I tried from far away, so I'll just be talking from far away, but it doesn't really show here. When I try showing it, if I try writing something really small, like here you see it, but then as I get further and further and further away, you don't really see it. So that's how I'm gonna do things. All right. Bear with me. All right. So today's lesson, we're gonna do some real quick work to get into the introduction of our lesson. So if you're in grade 11, then you probably know sine, cos. I need to figure out a better way to show this. Sine, cosine, and tangent. Right? You know all these, and then if we have a right angle triangle from here, then you probably know how to figure out the length of a side using it, or the angle using it, using wait a second. Sorry, I thought I was doing something wrong, but I was doing it right. So it was you see that just fine. So Katoa, where we have this for any angle I believe, theta. To find this angle, if you have to find any side, this is right here is the opposite, and right here is the hypotenuse. You know that opposite hypotenuse. So sine of theta is equal to the opposite of the angle, and over the hypotenuse of the angle. And if this was an angle, this would be the opposite right here. If this was an angle, this would be the opposite right here. God, I got to figure out a better way to make this video. Let me pull the laptop up close so I can actually see my preview. Yeah. Let me just move kind of like so. Let me bring the worksheet. And alright, this works. So yeah, this works. And then is cosine of theta, is equal to adjacent, because this side, which is not the hypotenuse, is adjacent to the angle over hypotenuse. Then, alright, tangent over, is equal to opposite over hypotenuse. So, you all know that. So, what we're going to try to do here is proving the identity real quick. This is an introduction to the lesson. We want to prove the identity of sine. We want to prove that sine is equal to y over r. And then we want to prove that cosine, oh sorry, there's a theta here, is equal to x over r. Alright? I'm actually going to switch to this one because for more precision. Oh, this one kind of sucks. I'm going to switch to the blue one. So, sine is equal to r. Now, sine is supposed to represent an angle, right? So let's just have this plane of x and y. Right here is positive. Right here, x is positive. You know graphs, right? And this is our angle. This is 360. Okay? So that's what we're doing. We have let's just say we have an angle pointing this way. This is our angle. So what we usually do to try to find that angle, because sine is going to only give us something called a reference angle, is we make a little reference angle and we call it alpha. And then through this reference angle, we make a kind of triangle. We extend this downwards, and that's there. This is our y, and this is our x. And this is r. So, when we find a right angle triangle, for a right angle triangle, let's just say this is theta instead, so I can show you. The opposite is y, and the adjacent is x. And if this, and this is r. Alright. So using this, let's just draw this again. We're able to prove that here this is r, this is theta. We're able to prove that this is y and this is x. Now, we know that from the circle as I showed before, from the circle plane. But now we have to prove this. Sine is sorry, not sorry, my bad. Which is, we take the angle, we take the opposite, and we put it over the hypotenuse. So y over r. Which is correct. Alright? For cosine, it's adjacent over hypotenuse, so it's x over r, x over r. And what do you see here? X over r. Okay. Let's get this done real quick. Now, let's just say I put a sine right here, sine theta over cos theta is equal to sine theta over cos theta, y over r over x over r. Just like that. Now that I think of it, I didn't need to show my face to do this, but whatever. This is how you do this, right? Now, one thing we could cross multiply. Let's do this real quick. This is equal to, for those of you that cannot see it, y over r divided by x over r, right? So which is then equal to y over r times r over x, right there. So then we do this one more time, and we get yr over xr. We could take out some r because it's multiplying, and we're left with y over r. If we look back at our triangle here, I'm just redrawing the triangle. If we look back at our triangle here, you'd find y is right here, x is right here. What does that remind you of? Opposite over hypotenuse. So as such, sine of theta over cosine of theta is equal to tangent of theta. So that's one thing we had to prove. That's one identity we have to prove. We're getting somewhere with this, don't worry. Now, another thing we want to prove is the Pythagorean identity. So, Pythagorean theorem. Sine squared, I'm not saying theta because I'm lazy. This is how you write sine squared. You don't put the square out, you don't put it in brackets. Normally you'd think it's sine theta in brackets squared like that, but this is how you write it without the brackets, plus cos squared is equal. Now, the reason we're doing this one, it looks kind of like the Pythagorean theorem. So we're gonna do this real quick. Right, what we got right here is y over r, if you remember from last identity, squared plus x over r squared is equal to something. We're trying to figure out what it's equal to. Now, oof, my knees. Now, this is equal to y squared over r squared plus x squared over r squared. You could get that out, alright? Now, what this gets you is y squared plus x squared over r. Alright, so this is what you get. This is an x and a plus, sorry for my messy handwriting. And if you remember from our triangle, let me do it again, sorry. Here's our triangle, alright? This is our triangle. Okay? X, Y, R. R is the hypotenuse, and remember how you get the hypotenuse in a right-angled triangle? A squared plus B squared, A squared plus B squared is equal to C squared. So this is equal to R squared, so this is equal to R squared over R squared, which is equal to 1. As such, the value of sine squared plus cosine squared is always going to be 1. course, the theta has to be the same. If you get completely different thetas, it's not going to equal this. Anyway. Our last trig identity. This is the one that might confuse you, but I'll show it. Sine of theta tan of theta and cosine of theta. Tangent of theta. So this is, we're multiplying all of them together. Now what does that get you? Sine of theta. And here's a little hint of what we're doing. Remember what we said before about tangent? Tangent is equal to cos, which is tangent is equal to sine of theta over cosine of theta. And here's cosine of theta. Let's put a real quick 01 over these just to show you something. Since for multiplying, we could cross the bottom here and the bottom there, which leaves us with a sine and a sine up here. Now that gets us, because there's all the ones here and this is a 1, sine squared of theta. So this equation right here is always going to be equal to sine square of theta. Now, this is going to be really helpful for later lessons, but this is what we want to memorize. Now, so what we're doing is, what we're going to use these for is for a kind of type of problem solving. For example, let's take tangent squared of theta is equal to 1 minus the cosine of theta, you can't see that, 1 sine of theta over, oh, this is squared, cosine is squared, over cosine squared. So, how do you prove this is equal to this? You want to prove it. That's what you want to do. Okay? So, we usually take the more complicated side. See this? We can't really do anything with this, although sometimes you want to do it. You can do something with this, theoretically, yeah. But this is a more complicated side, so it's much easier to work over that and simplify it than decompose this. Although I'm gonna probably show you both ways. So, real quick. Our right side is equal to this. You don't want to just straight up say left side is equal to right side. We just want to start with the right side and prove that this is true. Okay, this is fair. Now, something to note about this equation. Remember when we said that cosine squared plus sine squared is equal to 1? Well, if you move anything from this equation, let's just move this equation around. Because cosine squared and sine squared is equal to 1, that means that 1 minus sine squared is equal to cosine squared. And 1 minus cosine squared is equal to sine squared. Yeah. Okay. So, what this means is the top half right here is equal to sine squared. Cosine squared. Now, what did we start with? We started with tangent squared. You see that, right? Tangent is equal to sine over cosine. So when you square it, when you square this, you get sine over cosine squared, like that. Now you put it up here and you get sine squared over cosine and over cosine squared. Right here. This is what tangent squared is. And look what we got from here. So, therefore, for right side, we write right here, right side is equal to this, which is equal to that. It's equal to the left side. So that's what we're doing. We get to equations like these, and we kind of want to prove that this is true. So that's why the very beginning of this was important. So I'm not going to waste your time anymore, and I'm just going to tell you about the last one. If we started from here, like we said, tangent squared is equal to sine. We started out with the left side. It's equal to sine squared over cosine squared. So you notice the bottom is equal to the bottom of the other answer right there. So we already got this done, so we need to do stuff up here to get it equal to this, which, according to our theorem, 1 minus cos squared is equal to sine squared over cos squared. And you got that, which is equal to the right side. So this is how you do it on the other side. And that's what our unit's all about. It involves problem solving, especially if you get an equation like, for example, let me show you this one. Here, let me just... If you get an equation like this one, you require lots of problem solving to solve that. So, ow, my knees. So that's today's lesson. I'll do this tomorrow again, and I'll do that over that. Hopefully that helps drill lessons into my head, which prevents dumb mistakes. Like, I'm good at math, it's just the dumb mistakes, but... yeah. Bye-bye. Bye-bye.